Myself, Kumari Shraddha Sononi. My seminar topic is Symmetry Element and Symmetry Operation. Symmetry of a molecule. Any object or molecule is said to be symmetrical if it can take one or more equivalent configuration by exchanging atoms or groups in a space performing some operation on it. Symmetry element and symmetry operation. Symmetry operation. It is an operation performed on an object which leaves it in a configuration that is indistinguishable from and superimposable on the original configuration. Rotation about an axis, reflection through plane, and inversion through point are examples of symmetry operation. Symmetry element. Symmetry element is a geometrical entity exists within the molecule. It can be an axis or plane or point about which symmetrical operations are carried out to result in equivalent configuration. Axis, plane and center are examples of symmetry element. Types of symmetry element and symmetry operation. First, plane of symmetry and reflection operation. If a reflection of all parts of molecule through a plane produces an indistinguishable configuration, the plane is plane of symmetry. Plane of symmetry must pass through the geometry of molecule. Standard symbol for it is sigma. Plane of symmetry divided into three categories. First, horizontal plane of symmetry. This is perpendicular to the principal axis of symmetry and it is denoted by sigma h. Second, dihedral plane of symmetry. The plane which bisects the dihedral plane. It is designated by sigma d. Third, vertical plane of symmetry, which passes through the principal axis and one of secondary axis is present. It is designated by sigma v. Mirror planes sigma of BF3 molecule. Mirror planes can contain the principal axis sigma v or be at right angles to sigma h. BF3 has one sigma h and three sigma v planes. Dihedral plane of symmetry in H2O molecule. A special type of sigma plane which contains the principal rotation axis but which bisects the angle between two adjacent twofold axes is labeled sigma d. Second, axis of symmetry and proper rotation. The symmetry operation of rotation about n-fold axis. The symmetry element is denoted by symbol Cn in which angle of rotation is 360 degree by n. N is an integer. Example 2, 3 or 4. Applying this notation to the BF3 molecule. BF3 molecule rotation carried out through 120 degree. Here angle of rotation is 120 degree. Therefore n is equal to 3. That is BF3 molecule contains C3 rotation axis. Principal axis. If a molecule possesses more than one type of n axis, the axis of highest value of n is called principal axis. It is the axis of highest molecular symmetry. For example, in BF3 molecule, the C3 axis is the principal axis. Third type, center of symmetry and inversion operation. If a molecule can be brought into an equivalent configuration by inverting the coordinates of every atom through the origin, that is, by changing coordinates of every atom, then the origin which lies within the geometry of molecule is called inversion center. Both inversion center and operation are designated by symbol I. After inversion, all atoms change their position. Example of center of inversion: ethane molecule and sulfur hexafluoride. In sulfur hexafluoride, all fluorine atoms change their position. Fourth type, rotation about an axis. followed by reflection through a plane perpendicular to this axis. If rotation through 360 degree by n about an axis followed by reflection through a plane perpendicular to that axis yield an indistinguishable configuration. The axis is an n-fold rotation reflection axis, also called an n-fold improper rotation axis. It is denoted by the symbol Sn. Rotation reflection operation in methane molecule. Here, firstly, rotation through 90 degree takes place. Axis bisect the HCH bond angle. After rotation, reflection through a plane that is perpendicular to the original rotation axis carried out. Last type, identity. Identity operator. All object can be operated upon by the identity operator. It is designated by E. The operator E leaves the molecule unchanged. Identity symmetry element E. Successive operations for NH3 molecule. When NH3 molecule on rotation through 120 degree, it gives equivalent structure. Again, on rotation through 120 degree, it gives second equivalent structure. Again, on rotation through 120 degree, it gives identical structure with first one. Summary table of symmetry elements and operations. Symmetry operation, identity E, symmetry element none. Operation, all atoms unshifted. Example, bromo, chloro, fluoro, methane. Rotation, Cn. Symmetry element, rotation axis. Operation, rotation by 360 degree n divided by n. C2, example, para-dichlorobenzene. C3, example, NH3 molecule. C4, PTCl4 dinegative molecule. C5, cyclopentadienyl group. C6, benzene. Reflection, sigma. Symmetry element, mirror plane. Operation, reflection through a mirror plane. H2O molecule. Inversion, symmetry element, inversion center point. Operation, inversion through the center. Example, staggered ferrocene. Rotation reflection Sn. Symmetry element, rotation reflection axis, that is improper axis. Operation, rotation by 360 degree by n followed by reflection in plane perpendicular to the rotation axis. S4, CH4 molecule, that is methane. S6, example, ethane staggered form. S10, example, ferrocene staggered form. Thank you.